Good afternoon. I know all of us are really hungry. So I think I'm standing between the lunch. I think there is one more session in this hall, I understand. Okay, so a lot of talks on AI. It's packed. All of you know all the models now. Assuming that all of these things are there, I am assuming that most of you are well versed in, at least have a very good understanding about AI. What my talk is going to talk about is more on how do we learn, how do we create organization which is self-learning, right? And there are aspects, there are knowledge which we have built within the organization, which can be a pointer for you, which you can build it on top of it further, right? So I have with me Shamir and Ajo also representing and who has helped me prepare this presentation. Thank you, Shamir. Thank you, Ajo. A brief about me, you can see all the other details out there. I work for Harman, I work for the testing team. We are largely focusing on testing, validation of our global automotive products, which we have. We have a lot of ready products, which I'm going to talk about. I'm also going to talk about what does Harman do, those of you who are not aware of. I'm also a runner. Those of us who are not into a fitness regime, highly recommend we do that, because to do all this AI/ML, we need to be staying fit. So I've written a book. Check it out there. The book is Every Step Matters. Okay, a brief about Harman. I'm sure most of you would be aware, but just for a collection of that, we have multiple businesses, primarily focusing on automotive, lifestyle, digital transformation services. In automotive, we are primarily in intelligent cockpit, connectivity, ADAS, the premium audio, the Ignite, this like the Play Store of car, yeah, and the cloud services. On lifestyle, we are in multiple things, yeah. I see most of the speakers, at least which I can observe, is from JBL. So JBL is part of Harman. And of course, we have the digital transformation services, which focuses on multiple other services from the, as a service which we provide. We are number one in multiple places, which I'm not going to read about. It's a brief history about Harman, just to put this in context. More than 75 years, I think we have been there. JBL is our many brands which we have around. And last 2 to 3 years, we have been largely working on our automotive-ready products. A lot of AI, ML aspects which we have utilized inside the product. I'm not going to talk about so deep inside that, but that's something which is out there. You can check it out further. We work with most of the OEMs out there. Most of the OEMs. The names are mentioned out there with whom we work with. These are our lifestyle products which we have, right from JBL to AKG, Harman Kardon, and the multiple other products which we have, and there are multiple pro solutions which we have as well. Some of the products out there. So I'm just going to skip that. Okay. So I'll set a little bit of a context in the context of automotive, right? If you see today, we talk about car is a software-defined. When we say software-defined, there are a lot of details behind it, right? There are multiple layers which we are talking about, right from the hardware. There's a hardware abstraction layer. There's a middleware and API. And on top of it, there are multiple applications which we are talking about, right? So increasingly, it is becoming more hardware agnostic, right? It's more centric from how we can bring more and more software aspects on top of that, and how do we create abstractions on top of these things. So how do we do this? And you can go into the further details if you see, right? There are standalone ECUs, there are linked ECUs, there are multiple functions which is on top of it, and if you see, there is also a lot of discussions around car being itself as a computer, right? We talked about CCU, central computing unit. There are domain controllers and so on. Right now, most of the cars which we see out there has a lot of wires running across. So increasingly, there are cars which are getting into central compute-based approach, right? If you see, and most of the things which would happen would be around the app side of things, where the car is not like you have sold the car, and after 10 years later, you go and upgrade your car. There are a lot of business models which is coming where you're going to make your money, make your revenue out of the services which you offered on top of it. So whether it is the different applications which you're selling on top of it, whether the cloud services and so on, whether the V2S. I'm going to give you a short demo or short video about the different products which we have. This gives you some perspective, those who are not from automotive. Now, why am I telling this in this context of AI/ML, right? So this also is bringing to the perspective that there is a lot of digitization that has happened, right? And wherever there are digitization, wherever there knowledge that is getting transferred, that's something where we can bring whether it is from a AR perspective or whether from a V2X, vehicle to infrastructure perspective, whether it is the our biometrics which is there, which can be utilized for seeing whether are we tired, are we drowsy, and so on, right? It can really help in really improving our safety and so on, right? So that's the perspective from which I am coming to speak about that, how this is going to help us in the long run. AI in the context of automotive has a lot of advantages if you see, right, what I just now talked about, whether it is on the autonomous driving, right? Or whether it is about predictive maintenance. If you see most cars which are coming in, whether major OEMs, whether it is Tata or MSI or Maruti Suzuki or Mahindra or the other major OEMs which we have, right? Most of them have their own apps where they tell you about predictive maintenance. I think there are a lot of analytics which is done behind it and so on, right? Manufacturing automation. We always say, in our organization, car is an extended living space, right? No more, if you have looked into the latest cars which has come in from the OEMs from India, I mean, whether it's the sound quality, whether it is in fact, recently, there are also a lot of, the Dolby systems which is coming in the car itself will give you an experience which maybe you may not go to theaters. I'm just kidding, right? Smart traffic and fleet management, right? The V2X. So we talked about vehicle to vehicle, vehicle to infrastructure, how we can get information from that, and that can be utilized for, how to, manage this better and give early indications to us that how, if there are some hazards which is coming in and so on, right? So there are a lot of other use cases which is there on automotive, which, AI and ML is opening up. A brief about us, like where we are utilizing this, right? We have multiple, unlike automotive where, typically it takes 8 months, sometimes 3 to 5 years or sometimes longer than that for the OEMs. We are talking about today, we are able to take to production something in as close as 1 year to 2 years, right? Almost like cutting down the time by 100%. This would not be possible if we don't have products which are ready, which can be customized. So there is a lot of work Harman has been doing in the back end to improve on this, and there are multiple ready-suit products which we are going to talk about. I have a short video which maybe team out there, if you can quickly play, that would help us to set the context of this.
This song slap. Turn it up.
1 sec.
Dad, you okay? Yeah, I'm doing great.
Shh, it's okay. Go back to sleep. Wow, so crisp. Hey, hi, how are you?
Wow.
Oh, can't forget you.
Maybe we can take a pause there and we'll come back to the presentation. I mean, there are a lot of videos out there. You can see, you can go to car.harman.com. I mean, I just want to give a quick preview. There are a lot of aspects which we have done in the back end, which I'm not going to cover in this presentation. That's not what I wanted to cover. Now, in the next few slides, what I'm going to talk about is that how we are utilizing the power of AI, in fact, generative AI, to really learn from our mistakes and so on. How many of you are in this group who are out there who are from a management background? Management means who want to, who is doing project management, yeah, some other kind. At least few hands I can see. And how many of you have lived enough or worked enough to see, who have heard about lessons learned? You did this mistake once and you want to kind of stop it happening again, right? I mean, this is something which we have been seeing time again and again and again, right? Lessons learned we have heard about, but how do we kind of utilize it and so on, right? That's something which we have done, I'm going to talk about. There are multiple use cases. 5 of them I will bring it to you, which we have utilized for our internal consumption. I always believe that while we are saving the world with respect to AI ML, as a company, when we are working and developing products and solutions, we need to take care of our way of working in a much better way. And there are out there AI ML tools which is out there, which can really help us do things but better, and our way of working can be really improved, right? There are multiple things. I come from a test background, so there is a lot of things which we have done on generating test cases automatically, learning from our systems to really reduce the number of duplicate tickets which we have, right? That can improvise to improve the cost of quality. There are also testing improvisations which we have done because we do a lot of testing on the aspects where the chimes has to be detected, and the testing, it's very difficult when we are going for road testing, right? And we do hours and hours of road testing where we look for detections, whether it's the CAN logs or whether it is the chimes which comes in. So it is very difficult to get a human or a tester to really identify by themselves. So we get those data, feed it into the system, and that can really identify if there are patterns of problems and so on, right? And there are also solutions which we have developed for predicting the quality, how good it would be that before you give a release, if you can at least get a prediction that how good the quality is, or at least from the kind of defects which you have found or you're seeing, you can say that, hey, there are high chances that these modules have problems, yeah? So that can be focused reviews around it, architecture reviews around it, and so on. Of course, I don't have to go through, you have seen this enough in the last 2 to 3 days about how does large language model works and so on, right? So, of course, there are multiple things which we're talking about. Like the biggest advantage of the LLMs is making the tasks more simplified when the inputs are given from multiple directions, whether it is text, images, audio, code, or many other things, right? Whatever we are pushing in, and based on that, how do we kind of make the things more simpler? Let me go to the text-based solutions first, right? So, if you see, right, the first one comes is lessons learned database. Do your organization have a lessons learned database? It's lunchtime, I know, but please participate. Otherwise, it becomes, you don't want to just me to give a speech and go, right? The purpose is to really involve and create pointers to all of us. And I think that's the purpose of this conference, right? To create pointers to us that not everything would be, you will just adapt as is, but some pointers that can feed you and you can do something by yourself, right? I'm sure every organization has, right? Peter Senge has written a book called The Fifth Discipline. It's a very nice book. It talks about that how to build a learning organization, how to create mental models and the personal mastery and the knowledge which can be created so that the organization can learn by itself. Because the organization who doesn't learn, which will perish one or the other day. So our attempt here has been, when we talk about lessons learned, there are multiple things we learn, right? Whether from the mistakes which we do, or the practices which we have generated, the defects which we have created, the escalations which we get from customers, and so on and on. In fact, our biddings and so on. What our attempt here has been to really learn from our defects. We have years of data of different kinds of defects that came in. We feed it into a database, understand that what kind of defects which are coming in, what are the non-functional, whether it is performance-related defects, maintainability, whether it is security, safety, and all the other parameters, compatibility, interoperability-related defects, and so on. Because what happens is that when these informations are being fed, this has to be converted into the kind of vectors, right, so that it can be processed properly. And this is large data which we are talking about, right? That is where we've used different language models, large language models, to process this information and give it in a format which people can consume it. What would really make sense, the management team out there, right? What makes sense to you? You start a project, you're starting a new project, right? Whether you are a product development company or you are offering services or to anybody, right? What's the first thing you would like to know? What kind of mistakes, I'm sorry, I know I'm prompting questions and you don't have mic. I just want you to think about it. What kind of questions, right? Typical questions would be that, have we done similar kind of projects, first of all, right? That's the first thing. If we have done, what kind of issues have come in, right? What kind of issues have come in, whether it is performance, if performance, what kind of issues, so that it gives you a lot of knowledge that what you can avoid. If you have heard about failure mode effect analysis, FMEA, right? People who are from largely automotive and mission critical system, we can't afford to make mistake here. These are mission critical systems, whether it is, you're talking about airline industry or such mission critical industry, the mistake is very costly, right? In such places, it really helps us to really get this data and create failure mode databases and help it and build it on top of this further. So whatever we have kind of grayed out because of, we have make it anonymous so that the sensitization of information can be removed. But the point is that there are large chunks of data which you see, the bigger boxes. Those are the system where there are maximum challenges or system which we need to be focusing on. You can further drill down, zoom into that particular domain or component. You can also find out where are the hotspots and so on. Okay, that's the first part. Another use case. This is a test case generator. I'm sure you and your organization would be using some of the other, whether it is Copilot or any of those models or large language model from Meta, which you have used and so on, right? Some of the language models you will be using. If not, you should maybe give it a try. What our attempt here has been that, like many of our previous speakers talked about, is what contextualization. How do we bring context to these models, right? Like if there is no context, you cannot take a open source, code or whatever which is there with no knowledge inside, and then the prediction will not work here. So in this case, we have large amount of test cases which we have over the last years of experience which we have. We are teaching this model. What are the different kind of test cases which we have, different components, and so on, right? Whether it's from audio, media, Bluetooth, connectivity modules which we have, whether it's navigation, and different kind of tests which we have, we feed the system. And this can also help us, like typically we are asking to a chatbot, whether it is Copilot or to ChatGPT about generating test cases. Our tester uses this to create test cases, and help us and so on. I'm going to skip this, and if you have questions, we can talk about this in greater detail. I mean, the biggest waste is to, do things which nobody wants. How many of you have done analysis about duplicate defects in the system? The moment you are a small company, you are in a startup with a 10-member team, this does not make a big difference. But the moment you become 50, 100, and a 200-member company where you have different teams testing it independently and so on, there are challenges that you may not have day-to-day collaborations. It's difficult, right? And there is where duplicate defects identification is very important. So there are also systems or tools which we have developed to see what kind of defects which are duplicate, which is already there. You don't have to raise it. Just see that if this is existing, you can just club it with that and so on. So this is another thing which we talked about. Let me get into a couple of more points about audio-based solutions which we have. You have heard about telltales, right? Whenever you go in your car, whether it's a warning signal, put the seat belt, and on and on and on. There are so many, chimes that keeps coming in. Do you take actions out of that, or anyway? It's saying something, right? So one of the challenge which we used to have for the chime detection is that when you are going for road testing, there are multiple kinds of sound, right? It's not like there are, road sounds in the road, vehicle noise, and so many other noise that comes and clubs together, right? So really identifying from a human perspective, all of this thing is very, very difficult. So really training the model with respect to what is the right chime and what is not the right chime, and really, removing it and detecting it and doing the right kind of test was a challenge. And we have developed this based on our own, understanding and our own knowledge. This is a large amount of tests we have developed around it to really do the chime detection and helping us and so on. I'll talk about this forecaster system. Now, everybody wants forecast, right? Whether it is weather, whether it is earthquake, or any of these things. Do you have a forecaster system within your company where you can really predict whether you can deliver on time or not, whether your quality is good or not, right? Of course, this is no way complete at this point of time. While I'm speaking, we are learning from our own knowledge what we have, right? One of the things which we are trying to do is forecasting the defect trend for the upcoming sprints, right? Based on what we are developing, we are extracting the data, and then training the model and seeing that where are the hotspots, right? This can really help us to understand that I think data doesn't lie, right? If you have over the last 6 months or 8 months, if you have tested and you have defects coming in, your defects curve cannot be zoom, just coming down like this. And suddenly everything has become 0 defects or only few defects, right? If you have worked sufficiently enough in software industry, you would know that, how many of you used a curve called Rayleigh curve? I mean, there used to be, if you have to do a scientific way of predicting that, okay, whether the way things are going, whether it will really converge correctly or not, we used to use that. I think this is a similar method what we have developed, is that there are high chances that you are not going to organically make it happen, right? You need different kind of mechanism. Either people have to, more people are required with the right experience. There are also buggy modules which we flag it early so that actions can be taken, and we display the hotspots which are there in different parts and so on. So that's something which we have also developed in the bigger scheme. I have 5 minutes left. I would like to keep the points open for more questions. The bigger point, what I wanted to bring out of all of our discussion is that we are doing a lot of stuff, not only our products which we are developing, whether it is, if you have seen in one of the video, there was a father-son duo. Father was driving the vehicle, and did you understand what was the video about? Hopefully, it's a cognitive intelligence, right? In that, basically what we are trying to do is, we are collecting the information with respect to how drowsy the person is. So basically there are multiple algorithms which we have worked on it, and improvised, and with multiple data. A lot of data has been fed, and based on that we can really detect if somebody is drowsy or not. And if there is drowsy, there are multiple other parameters which is fed, like for multiple actions which is being driven. One is, you see the sound suddenly increases, and the guy who had the headphone, he opens it, he asks that, hey, Dad, are you okay? Right? While I'm speaking, we are working with multiple customers to deploy this solution. There are also other actions which starts, like we are also working with our partners, for, the seat partners which we have, who can help you, maybe give necessary massage, yeah, to say that, hey guys, are you okay? Do you need a break? And so on. So, and there are multiple other indications which can be brought in. But that's on the product side, right? This part which I covered in a little bit more detail was about giving focus on how do we improve our coverage, our test coverage, our test case improvisation. How do we learn from our mistakes, right? Because if you see, right, we are doing the same mistakes again and again, and which can be avoided, right? And before you go into development into a new product, it's very important that you see what are the different patterns of issues which are there, and if you can take some actions out of that and so on. And of course, there are a lot of other actions which we are talking about, predictive analytics, right? Whether it is quality outputs. There is also some things which we are also working on, which I have not brought in on, based on our, I think, morning, we also talked about observability, right? We are creating a model on observability based on the pattern. I tell to my team that we are talking about testing without testing, right? Now, how do you test without testing? Because you don't have to test, because already the system, the way it is behaving, you can make output out of this, right? So, a lot of outputs which we are taking from our observability engineering to push that in our CI pipeline, and we are also building some models around it, which is work in progress in some sense. With that, I will take a pause and take questions.
Ladies and gentlemen, the mic is there. We have, let's get the, we have somebody standing already.